Here's practice 11.7. So first we're going to find the surface area of some cones. So if I were to cut open the side of this cone, if it's made out of paper and I laid it flat into what's called a net drawing, my net drawing would look something like this. This part would kind of fold up into the cone, and then there's this circle that goes at the end. So if that was made out of paper, maybe something like that. Okay, and 6 is the radius of the circle. And the 14 is going to be the lateral height of the cone. So you could think of that as going, it would be 14 up along that seam, but you could also put the 14 in this kind of a position. Okay, and so to find the surface area, I'm going to have to find the area of these two figures. Now the circle is pretty straightforward. My area is going to be pi r squared. So that's going to be 36 pi. Okay, but this figure takes a little bit more work. So what I'm going to do to get that figure is to look at, I'm going to kind of treat it like a triangle. It's not a triangle, I know it's a sector, but we can actually find it using the triangle formula like this. Okay, so the height is going to be 14. The question is, what is the base? Well, let's think of the base as this curved part down here, okay? And if you were to fold the cone back up, that curved part would be the same as the circumference of the circle. So that means I can just use the circumference of the circle, which would be 2 pi r. Okay? So the radius of that circle is 6. So that gives me 12 pi, okay? So that means that that blue part there would be 12 pi. So yeah, I can write that in there if you want. So that is 12 pi here. And now I can find the area of this sector here, of this piece of pie. Okay, so half of 12 is 6. 6 times 14, let's see, that's 16, 24, 84. So this is going to come out to 84 pi. Okay, and now to get the whole surface area, I just add those two bits together. These two bits, right? And so that's going to give me 120 pi, and it would be this many square feet. You could also do a decimal approximation. 120 pi is about 376.99. Again, square feet, because this is surface area, so it's really area. Okay, exact same kind of process on this next problem. So I'm going to draw, I always like to draw a net on these, a net drawing, what it would look like flattened out. This time they give me the diameter, but that means that the radius would be 9, right? Just watch out there, and then my height here is going to be 10, and I just need to find this, which again is going to be the same as the circumference of that circle. So 2 pi r, that means that's going to be 18 pi. Okay. All right, so now we can find the area of both parts. My area here, I'm thinking 1/2 base times height. It kind of resembles a triangle, even though it's not a triangle. My base would be 18 pi, and my height would be 10. Okay, so half of 18 is 9. 9 pi times 10 would give me 90 pi here. And then down here for the area of this, don't forget about the area of the circle, pi r squared. Area of that is 81 pi. And then add together both bits. Oops, 90 pi plus 81 pi. So that would be 171 pi. This is square meters. Or as a decimal, let's see, 171 pi is about 537.21. Okay. All right, and then moving on to volume. Volume for a cone is actually, it's the same formula as it is for a pyramid. 1/3 of the area of the base times the height. The only difference is how you get the area of the base. And since cones, the base is always going to be a circle, that means we're going to use pi r squared to get the area of the base. So there's my formula. Okay. All right. So for this first one, the radius of the base is going to be 5. And then the height of the cone, not the lateral height, but the height of the cone is 8. So I want to use that 8. Okay. So let's see, I've got 1/3 of 25 pi times 8. Okay, so this would come out to 200 pi over 3. That's that many cubic centimeters. 3 doesn't go into 200, so you could leave it like that, or again, decimal approximation. It's going to put me at about 209.44. Oh, I'm off screen a little bit, sorry. 209.44 cubic centimeters. Or there's the exact version, okay? And it doesn't matter if it's a right cone or not. This is still going to work the same. My height here, assuming that that's well, that does go to the vertex from the base. It looks like it's perpendicular. So yeah, this is going to be my height. So volume is going to be 1/3 of the area of the base. Area of the base, pi r squared, times the height. Okay, so 4 pi times 4 would be 16 pi, and then divided by 3. So this is going to be 16 pi over 3 cubic inches, or I don't know what that is. Let's check it out. 16 pi divided by 3 gives me about 16.76. Okay, on to the next page. All right, we've got some problems that are very similar to problems that showed up in earlier sections in the chapter. We've got similar solids. Okay, so it's not really any different from how this worked with prisms and cones that were similar. So we're finding the volume of cone B. Okay, so if I call this x, some people are going to say, oh, 9 is to 12 as 72 pi is to x. And they are wrong. That's incorrect because then you're using the sides to compare the volumes. So I was using the side ratio to compare the volumes. That's not going to work. I need the volume ratio. Okay. So first, let's find the side ratio. Well, I use the 9 and the 12, and I'll reduce that. So 3 goes into both of those. That would be 3/4 reduced. Okay. And then to find the volume ratio, I'm going to cube the side ratio. So I'll take 3 cubed over 4 cubed. 3 cubed is 27. 4 times 4 times 4 is 64. So my volume ratio is 27 to 64. So that's the ratio that my volumes should be in. So 27 is to 64 as my small volume is to my big volume. I don't know the big one yet, but now I can find it by cross multiplying. 27x is going to equal 64 times 72 pi, which would give me 4,608 pi. Okay, and then I just divide by 27. Okay, I'm going to check if that reduces. It actually does reduce a little bit. We can reduce it to 512 pi over 3. So you could say it like that. Or we could do the decimal version. I'll put it down here. Okay. Which would be about 536.17. Exact same kind of deal on the next problem. So my side ratio, call this the similarity ratio, it'd be the same thing. So it would be 4 to 2, or you could go 2 to 4, it doesn't matter. So I'll do, actually I'll do 2 to 4 just so that I can keep this as a fraction. So when I reduce that, that's 1/2. So that's my side ratio. That means my volume ratio. I'm going to square that. No, I'm not. That would give me the area ratio. I'm going to cube it. So my volume ratio is 1 to 8. So 1 is to 8 as my small volume, which I don't know, is to my big volume, which I do know. Okay, and then cross multiply, so 8x is going to equal 28 pi. We can reduce that. Let's see, that'd be 14 over 4 or 7 over 2. So this is going to, x is going to equal 7 pi over 2. And this would be inches cubed. And as a decimal, 11.00 if I'm going to the nearest hundredth. Okay. All right. Next up, we've got some composite solids, and that just means we have two different solids put together. So for volume, all you have to do is find the volume of both components and then add them together. So let's find the volume of the cone. So the cone, here's my formula. The area of the base, well, the base is a circle, so pi r squared. And then the height would be 7. Okay, and then 16 times 7 is 112, so this is going to give me 112 pi over 3. And can't reduce that, so I'll just leave that like that for now. And then let's find the area of the cylinder. Not the area, the volume of the cylinder. For a cylinder, I'm going to just take the area of the base times the height. And again, the base is going to be a circle with a radius of 4. So pi r squared. And then my height is going to be 15. So 240 pi. Okay, and then I just add these two components together. So I could get a total volume then is going to be okay, so if I wanted to combine these, I'd need a common denominator over here. So let's go ahead and do that. 240 times 3 is 720. I'll just write that like that. And this would be 720 thirds pi. So 720 plus 112 is 832. Let's see if I can reduce 832 over 3. I don't believe I can. So you could leave it like this. This is this many cubic inches. Or as a decimal, I've got 871.27. Okay. All right. And our last one, what we have is we're going to, for our volume here, it's a cube with a cone cut out of it. So for my volume here, I'm going to take the volume of the cube minus the volume of the cone. So let's find the volume of those two components. Okay, so for my cube, volume is area of base times height. The base is 4 by 4 square, and the height is also 4, or you could do length times width times height, and that's going to give you 64. Okay, and then for the cone, okay, well, we need two things. We need the, so I've got 1/3 area of base times height. So to find the area of the base, I need the radius of the circle. Well, if it's 4 from one end of the box to the other, that means it's 4. The diameter then would be 4, right? If this diameter is 4, that means the radius is half of that. So the radius is going to be 2. Okay? And then I need the height of the cone. Well, that's the same as the height of the box because this fills up the whole box. So this is also going to be 4. Okay? And then I got everything I need there. So let's see. 1/3, and then pi r squared, so pi times 2 squared, and my height would be 4. So I've got 1/3 of 4 pi times 4. So 1/3 of 16 pi, 16 pi over 3 you could call it. Okay? And then so going back up to the top, I was doing cube minus the cone. The cube was 64. And the cone is 16 pi over 3. And I guess you could write this in terms of thirds to combine it, but they're not going to be like terms anyways because one of them has a pi and one of them doesn't, so you could leave it like this. It's that many cubic centimeters, or you could use a calculator to simplify that. So first I'm going to find 16 pi. I'm going to divide that by 3. I'm going to do 64 minus that. Okay, and that gives me about 47.24. And it is that many cubic centimeters, and that is the end of the practice assignment. And I'll see you next time.